Modern astrophotography has come a long way since the introduction of the digital camera, and advances in hardware and software have made astrophotography and astronomy much more accessible. These days, with ordinary astrophotography equipment, we can capture images that not long ago required gigantic telescopes housed in multi-million-dollar observatories. How far has this technology gone? The image you see of the Horsehead Nebula that we are now zooming in on? This data was captured by myself using a relatively inexpensive astro camera and refractor telescope at the new Microstory observatory. And the subject you see in this video, the Horsehead Nebula, presents us with a great opportunity to compare and contrast what can be done with the equipment we might pick up from any astrophotography store with the capabilities of orbiting telescopes such as NASA's Hubble and ESA's new Euclid. Because only a few years ago, the Hubble telescope was used to create incredible visible light and infrared spectrum images of the Horsehead Nebula, and much more recently, ESA's brand new Euclid space telescope, hovering at the L2 Lagrange point, was also used to image the Horsehead Nebula. Of course, NASA and ESA are using equipment valued in hundreds of millions of dollars. We astrophotographers here on Earth, operating out of our homes and backyards, will be using equipment of a much more moderate cost. For example, the 80mm refractor and planetary camera I use together cost less than $2,000 Canadian. But first, a little background about the Horsehead Nebula. The Horsehead Nebula and its companion, the Flame Nebula, are two of the most interesting objects in the night sky, in my opinion. Like so many nebulae, they are birthplaces of stars, and the Horsehead has fascinated astronomers and laypersons alike for centuries. How strange it is to think that out there in space somewhere, there is a vast cloud of stardust that looks something like a horse's head. Though, to be honest, I don't think it really deserves the moniker as much as another celestial structure in the Cygnus Wall. This, to me, looks far more like a horse's head. I'm surprised it's never received a similar moniker. This entire region below the glowing cloud is filled with dust and gas. Hence, many more stars and celestial objects are visible above the cloud than below. In the darker areas below the Horsehead, dust absorbs and obscures starlight. And if we change the nature of which light is emphasized by recompositing the image, we can amplify detail in the visible spectrum that brings out some of the edge detail of the billowing mushroom cloud, which is essentially what the Horsehead is. And one can see bright vertical streaks above, left, and right of the Horsehead, which is nebulous material that has been striated or combed by magnetic fields generated by the stars in the region. If we were able to pass over the horse's head, we would drop the illusion of a horse figure altogether. That is nothing but a gestalt, which is to say that our brains are designed to perceive images and patterns that we are familiar with from Earth. So often, when we look at the stars, our brains want to perceive things that simply are not there. This, fundamentally, is how and why we perceive constellations and figures of animals, mythical creatures, and gods among the stars. These are not optical illusions, but rather a misunderstanding generated by how our brain wants to see things. Let's switch to the imagery that can be perceived through the Hubble telescope. It is inarguably quite good, yet, interestingly, these initial images are not much better than what can be obtained through modern astrophotography equipment. But when the Hubble observes the Horsehead Nebula in the infrared, now we get a glimpse of the structure's true wonder. The gases of the stardust that comprise the Horsehead are cooler than the surrounding gas. Switching to an infrared perspective brings out their details, and we can see their traces and whiffs, as well as gain a better view of the nascent stars hidden within. But recently, the European Space Agency has set online the Euclid orbital telescope, a powerful instrument with unique ability to gather extremely detailed, wide-field images with over 600 megapixels resolution. Technological advancements have made what modern astrophotographers can do amazing, and in many ways we can even come close to matching the capabilities of NASA's best telescopes. But the Euclid sets a new bar. Not only does it set this bar, but in this image, it reveals secrets hidden within the Horsehead Nebula that otherwise we might have barely noticed. Euclid's ability to resolve both visible light and infrared spectrum objects opens up the perspective on a whole realm of stars and structures deep within the dark stardust below the formation of the Horsehead. It can even reveal galaxies up till now hidden behind that stardust, and astronomers hope to be able to use this technology to find new brown dwarfs and identify new protoplanetary systems. The technology reveals faint wisps of gas shaped by the intense magnetic fields and interstellar winds generated by young and energetic stars. And the speed by which the Euclid telescope can capture this data is amazing. The image I captured from the Skystory Observatory was the result of 8 hours of light collection, and it was still much less detailed. Euclid captured all of this in 1 hour, and it is the most detailed wide-field image of the Horsehead and its surrounding nebulae ever taken. Other telescopes, such as the Hubble, ground-based observatories, or even the telescopes and the observatories of amateur astronomers, can capture many of these details and see these faraway galaxies, though it takes much longer to capture that information, and images like this would have to be stitched together from multiple efforts. And there is simply no way from the ground, not even from the highest mountains, to escape the distortion of Earth's atmosphere. At least, not yet. The images captured by the Euclid are of such high resolution that they can be zoomed in on an incredible amount and still retain sufficient detail for scientific study, and even enough detail to maintain their artistic integrity. As we zoom in on the gaseous material that provides the violet backdrop to the Horsehead Nebula and its associated cloud, we can punch through the haze, so to speak, using Euclid's tremendous infrared and visible light resolving power, and see a distant universe from billions of years ago. And if we keep on zooming in, and it is amazing just how far we can zoom in on the data captured by the Euclid with its mighty 600 megapixels of resolution, we can bring into view ancient galaxies of unimaginable distance, millions and billions of light years away, a vast scattering of galaxies, thousands, one after the other, hidden in the distant universe behind the shimmering cloud around the Horsehead Nebula. The powerful star, Sigma Orionis, out of sight here but above and to the right of the Horsehead formation, provides the light that illuminates much of the Horsehead Nebula and the surrounding cloud structure, so much so that it casts a shadow below and to the left of the Horsehead formation. But if we zoom into the gas cloud, far in, and peer through the obscuring haze of all that swirling dust, Euclid's powerful telescope reveals yet more galaxies hidden behind the folds of this nebula, evidence of the tremendous capacity and resolving power of this most recent orbital telescope. I would love to be able to match this type of resolving power. Imagine the contributions we, amateur astronomers and persons operating home observatories, could make to the scientific community if we were actually able to resolve images like this. But who knows? The capabilities of modern astrophotography equipment is increasing almost exponentially, and we can contribute with what we have now to the science of understanding the universe all around us. And along the way, we can enjoy the beauty and the wonder of places such as the Horsehead Nebula.